and a blueprint for observatories all over the world. This observatory is the vision of one man, George Ellery Hale. His mission: to solve the greatest mysteries in the cosmos, to find out if there is anything beyond our galaxy. This is the first step. To see deep into the cosmos with stunning clarity, he needs his new observatory to house the biggest telescope in the world. Telescopes are like light buckets. The larger the telescope, the more light it can gather, bringing the faintest stars into focus. But Hale faces a challenge. Most telescopes at the time use glass lenses to focus light. But when glass lenses get really big, they bend under their own weight, causing distortion. Glass lenses just can't get any bigger. What Hale needs is a radical new design. A giant telescope that can collect a lot of light, but which doesn't use lenses. So Hale turns to a telescope first created by Isaac Newton in 1668. The reflector. This kind of telescope uses a curved metal mirror instead of glass lenses. It focuses light by reflecting it to a point. Now, Hale is planning to build one on a scale that has never been seen before. Only revolutionary engineering can support the gigantic instrument he plans, and the project will take 11 years to complete. The curved mirror spans 100 inches in diameter and weighs 9,000 pounds. It sits at the bottom of a 40-foot cast iron cube, housed in a 100-foot diameter dome. Finally, in 1917, the biggest telescope the world has ever seen sparks wonder amongst the public.
The scientific eye of America. To this mecca of stargazers flock astronomers from all nations.
In the pantheon of telescopes in astronomy, Mount Wilson, it is no exaggeration to say, is probably the most important telescope in the history of cosmology.
Discoveries that were made here really put it onto the map.
This great telescope is soon directed towards one of astronomy's most enduring mysteries. Strange, fuzzy clouds of light hanging amongst the stars have puzzled astronomers for years. They are the nebulae. Some are egg-shaped swirls. Others are delicate spirals of stars. Others have branching tentacles. Thousands of them are visible through telescopes, but nobody knows what they are or how far away they are. Some astronomers believe that certain types of nebulae could lie outside the edges of our Milky Way galaxy. They wonder if they could be island universes, galaxies like our own. If so, this would shatter the limits of the universe and our understanding of it. But they have never had the technology to solve the mystery, until now. Hale invites the world's best astronomers to help crack the mystery once and for all. Among them is a young man called Edwin Hubble.
Edwin Hubble he made a tremendous number of important discoveries.
Night after night, Hubble examines the nebulae with the 100-inch telescope. He examines one in particular, the Andromeda Nebula, which Hubble can now see in unprecedented detail.
It would be this 100-inch telescope that would finally be powerful enough to bring the nebulae within reach. and would start a series of discoveries that just completely changed our understanding of the universe.
Hubble can see stars within the Andromeda Nebula, but to find out if it really is an island universe outside the Milky Way, he has to find out how far away it is. But that is not an easy task. Establishing distances in the vastness of space is one of astronomers' biggest challenges. Stars, like car headlights, appear brighter the closer they are. If you know their true brightness, you can work out their distance. It's like knowing the wattage of a light bulb. If you don't know this, you have a problem. As NASA astrophysicist Kim Weaver explains.
At that distance, the headlight on that car appears to be the same brightness as the headlamp on this bicycle.
But as the headlights get nearer, it becomes obvious that their true brightness is in fact greater than that of the bicycle lamp. It's the same with stars.
If we know how bright a star is intrinsically, we can work out how far away it is from us. And that's what we call a standard candle.
Luckily for Hubble, astronomers had recently discovered a special type of star with a true brightness they can calculate. It is called a Cepheid variable. And it's recognizable because it pulsates over a period of days. All Hubble has to do now is find one of these stars in a nebula like Andromeda. At night, he scans the heavens with the 100-inch mirror. By day, he analyzes the photographs he has taken, hunting for any stars that have changed brightness. Then, on October 6, 1923, after months of work, Hubble strikes gold. A Cepheid variable on the edge of Andromeda.
I'm looking at the original discovery plate of Edwin Hubble, where he first found a Cepheid in the Andromeda galaxy. And he actually marks on this plate between two black lines where the position of the Cepheid is, and he writes VAR exclamation mark when he realizes it's a Cepheid. So he's compared two different plates, and he's discovered that this thing is actually changing in its brightness.
Hubble can now make a measurement that will change history. The distance to one of the nebulae. He works out that Andromeda is about 800,000 light-years away. That's more than 8 times the distance to the furthest known stars in the Milky Way. This means Andromeda has to be outside the Milky Way, a whole new galaxy beyond our own.
This is irrefutable evidence. He's very excited. He writes it with an exclamation mark because he realizes the significance of the discovery.
Hubble's discovery explodes the frontiers of our universe. Our Milky Way galaxy is no longer all there is in the cosmos. Hubble goes on to discover that Andromeda is not alone. He reveals that dozens of nebulae are actually other galaxies.
Edwin Hubble's research with telescopes profoundly changed our view of the universe.
The most powerful telescopes of today are still exploring the wider cosmos that Hubble first discovered. Looking across billions of light years, they have uncovered 100 billion new galaxies beyond our own, each made up of 100 billion stars. Multiply those together, and you have more stars than all the grains of sand on all the beaches and all the deserts on Earth.
Just like that, the universe became 100 billion times larger.
Hubble's discovery that there were other galaxies outside our own blows the universe wide open. But what he discovers next will be even more extraordinary. Several years earlier, other astronomers had discovered that many of the nebulae, now identified by Hubble as galaxies, were moving away from us. Now, Hubble wants to work out why, and he will do it by analyzing light itself. He uses a method first discovered in the 1800s.
This is a spectroscope made in about 1880. One of the first generation of instruments used for analyzing the light from the sun. It's an instrument like this that transformed astronomy, because you can decode the light in a way that you'd never imagine.
The spectroscope splits white light into its rainbow spectrum of colors, and hidden in this spectrum are clues to the behavior of the stars. Light is made up of waves, and each color has its own wavelength. Blue light has a short wavelength. Red light has a longer wavelength. But when a galaxy is racing through the cosmos, the wavelengths of the light appear to change from our perspective on Earth. If the galaxy is moving towards us, the wavelengths get squashed and appear more blue. If the galaxy is moving away from us, the wavelengths get stretched out and appear to become more red. We call the effect redshift. It's like a cosmic speedometer. The faster a galaxy is moving away from us, the more its light waves are stretched towards the red. Sound works in much the same way, because it too is made up of waves. As astronomer Alex Filipenko explains.
Oh, this is going to be great. I'm going to blare on the horn now. Here we go. The pitch of the sound is constant, even though the car is speeding down the road.
In the driver's seat, Filipenko hears the horn at a constant pitch. It doesn't change. But now he wants to hear what the horn will sound like if he stands on the roadside, and the car drives past him.
When the car was coming toward me, the waves from the horn were being squished together, so the pitch sounded higher. And as the car passed me and moved away, the waves were stretched apart, so the pitch sounded lower. So it sort of went like that. If that blue car had been going fast enough, the high-frequency blue light would have been stretched apart, then the blue color would have shifted all the way to red. The car would have looked red to me. That's known as a redshift.
Back in 1928, Hubble is looking at the redshift of his new galaxies to find out how fast they are moving. He sets out to chart the speeds of galaxies both near and far. He wants to see if he can find any correlation between how fast they're moving and how far away they are. Night after night is spent painstakingly analyzing the light from galaxies. The final results are staggering. Hubble discovers that the farther away a galaxy is, the greater its red. So
a very interesting relationship between them. The nebulae that are farther away are moving faster away.
Hubble comes to an astounding conclusion. The universe is expanding. The galaxies may look like they are traveling away from us, but in fact, It is space itself that is stretching apart.
Here's a good analogy of how the expanding universe works. Now, this is a hypothetical one-dimensional universe where the ping pong balls are the galaxies and the hose is the space between them. As the space expands, all of the ping pong balls recede away from one another. And every bit of space expands. The more space there is, the faster the distant one looks like it's expanding away from us.
Hubble's discovery is one of the greatest breakthroughs in the history of astronomy. The universe is not static. It is growing bigger and bigger.
These galaxies are moving apart from one another because space itself is expanding between the galaxies. That was a marvelous discovery.
Hubble could never have made his discoveries without the 100-inch telescope on Mount Wilson. High above the plains of New Mexico, one of the most advanced telescopes of today is taking Hubble's groundbreaking work even further. The Sloan Digital Sky Survey is analyzing starlight from hundreds of thousands of distant galaxies. Each aluminum disk is a galaxy map for a small part of the night sky.
So we've got 640 holes on an aluminum plate. Each hole corresponds to a galaxy, many millions of light years away.
Optic fibers link each hole to a high-tech version of the spectroscope used by Edwin Hubble. It will measure the redshift of the galaxies. Then technicians insert the map into the base of the telescope and match it up to the right section of the night sky.
So you can get 640 spectra at once, which is a great way to get a survey done, much better than once at a time.
This survey has now calculated the speeds of over 930,000 galaxies, giving us a far more precise image of the universe we live in and how fast it is racing apart. But back in 1929, Hubble's discovery begs a new question. If the universe is expanding, what is it expanding from?
Hubble saw and realized that things were moving away from each other, and the natural leap from that is, well, if things are now moving away, weren't they all at one time in a central location?
Astronomers put forward a revolutionary theory, the Big Bang, a single moment in time when the universe was born. The idea is so revolutionary, scientists struggle to make sense of it.
We had no way to observe this phenomenon. It made no sense to people at the time. Even Einstein didn't believe in this idea. We didn't have the belief that it might happen, and we also didn't have the telescopes to observe the effects of the Big Bang.
To find the proof, astronomers will need a completely different type of telescope, one that can see what our eyes cannot. Beyond the colors of visible light are the rays of the electromagnetic spectrum that our eyes cannot detect. Gamma rays, X-rays, radio waves, and microwaves may be invisible, but they are crucial for astronomers. They hold the keys to some of the most violent events in the universe.
The human eye is only sensitive to a very small part of the electromagnetic spectrum. These are all the waves that behave like light. But we have been able to see in parts of the spectrum which are not visible to the human eye.
(1964). Astronomers Arno Penzias and Robert Wilson are working with a new radio telescope. Its giant antenna enables them to measure microwaves and radio waves in space in the form of heat. They expect the stars of our Milky Way to emit a faint glow, but when they point their antenna to empty space, where there should be nothing at all, they discover something very unusual.
We expected to find the sky away from the Milky Way to be quite cold, to be very close to absolute zero. And instead we found, to our very great surprise, that it was about 3 degrees hotter than that.
The mysterious signal seems to come from every direction.
We had a noise, a signal, if you want to call it that. Could be radio noise sources or something else, but I had no idea what it was.
Penzias and Wilson suspect that there is a defect with the equipment which is causing interference. They try everything, even sweeping the pigeon droppings from inside the antenna.
It didn't go away from winter or summer, day to night, seasons. We looked at every possible direction. There was a high-altitude nuclear explosion 2 summers ago, so maybe there was something in the atmosphere, charged particles. I didn't know.
Penzias and Wilson are at a loss until they hear about the work being carried out by a team of scientists just down the road at Princeton University. Robert Dickey and his colleagues have worked out that the afterglow from the Big Bang should still be felt today. They have even calculated the temperature, 3 degrees above absolute zero.
So I called up and I dialed Bob Dickey's office. And I happened to get him. And what I learned afterwards was that he put down the phone and he turned to his colleagues and he said, "Boys, we've been scooped."
Penzias and Wilson have unwittingly found the first physical evidence of the Big Bang. Their radio telescope has picked up the afterglow of the beginning of the universe. It remains one of the most important discoveries of all time.
I had no idea that we were listening to the echo of creation.
In 1978, Penzias and Wilson received the Nobel Prize.
To be on a list with Albert Einstein, to be on that same row, was almost too much. It was too much to bear. I just couldn't think of comparing myself against the people who have won Nobel Prizes.
In 1964, when the background radiation from the Big Bang was discovered, it was for the first time direct evidence